This video will cover Year 10 quadratics. So this is the solving one and the applications part of it. So A and B level questions in this one. I'll put some time tags in the description below so you can skip to question numbers or question types. In the first one, we're using the null factor method and we need to factorise these. So hopefully you can factorise them. Remember that this is sort of a couple of step process here. We look at this number first and then we look at this number. So I'm looking at 18 and I'm trying to write down factors of 18 that might make 7. So I've got 1 times 18, I've got 2 times 9, and I've got 3 times 6. And I would like to make the number 7. There's also a couple of other little hints here for me. I know that it's going to look something along these lines. Brackets times brackets equaling nothing. And because this here is a negative, I know that I have got a plus and a minus inside my brackets. If it had been a plus, they'd both be the same. And I'm looking for a pair of those factors over on the right there that are going to make 7. And I think that 2 minus 9 will make 7. So I'll say 2 minus 9, and that one's factorised. Null factors, nice and easy. Remember from the fundamentals video that all you need to do to answer this is say x is, and then you take those numbers and reverse the symbols. So it's 2 and positive 9, negative 2 and positive 9. But a better way of describing that, just so you guys understand how that actually works, is remember if I made x minus 2, then what I'd have is minus 2 plus 2 times by minus 2 minus 9. Doesn't really matter that this one here is minus 11 because if it's being multiplied by this one, which is 0, you're going to get the answer 0. And similarly, if I had made it so that x was 9, then what I'd have is 9 plus 2, which is 11, but that doesn't really matter because 9 minus 9 makes nothing. So that satisfies the equation. This is how null factor works. It means null means nothing, and factor, this is a factor, and this is a factor. So I'm trying to make one of the factors equal to 0 to solve it. Let's move on to the second question. In the second one, again, I'm looking at this number here. I want to write down the factors of 32. I've got 1 times 32. I've got 2 times 16. I've got 4 times 8. That might do for the minute, I think. I'm going to set myself up my brackets. I know it's going to be x. It's going to equal 0. And now, if I have a look at this one, see how that one's positive? That means both signs in the brackets are going to be the same, and that one's negative, so it means they're both going to be minuses. So that's just a little cheeky trick. Now I'm looking for two factors over there that will make 12, or minus 12, and minus 4 minus 8 will make 12, so minus 4 minus 8. Null factor, nice and easy, x will be 4, reverse symbol, or 8. Okay, question 2. We're going to use the quadratic formula for this one. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and remember that all of these equations follow this rule. We've got ax squared plus bx plus c, okay? So in this case, we've got a 2 being a, we've got a 5 being b, and we've got c being minus 9. And now all we do is just sub in and solve. So we've got x equals, might make that pen a little skinnier, minus 5 plus or minus the square root of 5 squared minus, put this in brackets so we don't get confused, 4 times a, which is 2, times c, which is minus 9, all over 2 times a, which is 2. Start solve, minus 5 plus or minus the square root of 5 squared is 25, minus 4 times 2 times minus 9 will give me 128, all over 4. Now it's asking me to answer this in third form, so I haven't got far to go here. Minus 5 plus or minus the square root of 25 plus 128 gives me 153 all over 4, and that's the final answer. We'll leave it in third form. That's sometimes called absolute because there's no error in rounding in that one. All right, moving on to question 2. Same thing. Formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Sub in. So we've got a value of a value of b, and a value of c. So x will be minus 3 plus or minus square root 3 squared minus 4 times 7 times minus 1 all over 2 times 7. Simplify, minus 3 plus or minus 3 squared is 9, 4 times 7 times minus 1, so minus 4 times 7 times minus 1, 2 negatives there, so 28 all over 14, nearly there, minus 3 plus or minus 9 plus 28 makes 53 all over 14, and that's my final answer. Alrighty, question 3. Question 3 is a worded question. There's a few steps to this one. We need to write an algebraic equation, and then we have to solve it using null factor. Okay. So a couple of things we need to unpack here. Product, first of all, that means times, and then I've got 2 consecutive numbers. That means one after the next. Now, what I don't want to do is I don't want to come in here and start writing, great, so x plus y as 2 consecutive numbers, because then I've got 2 things that I've got to solve for. So what I'm going to do is I'm going to let my first number equal n for number. You could use x if you wanted. And so the product of this number, so the first number times the second. Now, the next number is going to be one number higher than my first. So I'm going to call my second number n plus 1. Is added to 7 to give 1,129. So this is looking good. Now what we might need to do is expand this so that we can use the null factor law. So n times n makes n squared, n times 1 makes n, plus 7 equals 1,129. Now something that we can't do is use null factor unless our equation equals 0. So a bit of balance method. Let's take 1,129 from both sides, so minus it. Running out of room. So now my equation reads n squared plus n minus 1,122 equals nothing. Now all I've got to do is factorize this. So it's going to be n something times n something in brackets equals nothing. Now this is interesting because I need to try and find factors of 1,122 that make the number 1. That could be quite a long process because I bet 1,122 has lots of numbers. or lots of factors. So one way of narrowing it down is I know those numbers must be very close together. For starters, the question tells me that they're consecutive. And secondly, I need to make the number 1. So one way of doing this is over here on the side, on your scrap paper, or on the side here, I'm going to see what the square root of 1122 is in my calculator. And when I put that in, it gives me the answer 33.49, so around that to 33.5. And now what I'm going to do is I'm going to say, great, I'm going to go half a number higher and half a number lower and test them and see if that's going to work. So I'll tentatively put in plus 34 minus 33 and see if that works, because 34 minus 33 makes 1, so that would satisfy this. So in my calculator again, 33 times 34, yes indeed that does make 1122, so they are my factors. That means that, therefore, n is 33 and 34, the two consecutive numbers, or minus 33 and minus 34. Question 4 is not dissimilar to question 3. We've got to write an equation. But this time what we've got is we've got consecutive odd numbers. Now consecutive numbers are one that go one after another. So in the equation above you might remember that we called the second number n plus 1. Odd numbers are 2 numbers apart. So the next number will be n plus 2. So let's start writing ourselves up an equation here. We're going to let the number be n again. Just for consistency, you can use x or any letter you like. So we've got 2 consecutive numbers again. So product again, so times. So we've got n multiplied by this time n plus 2, because it's 2 numbers larger. And that is taken from, so subtracted from 3007 to give an answer, in other words, equals 704. Looks good. Let's expand it. We're going to use null factor again to solve it. So let's expand. We've got 3007 minus n squared minus 2n equals 704. Balance method. Let's get rid of that 704 on the end there. So take it away, minus 704. And as I write out the equation in the next line, what I'm going to do is I'm going to put it into the format that we're used to seeing it in. Doesn't matter, but it's just going to make it a little clearer for us so that a bit easier for us to work with. The other thing that we might do is we might just multiply everything here by minus 1, because otherwise we've got to deal with negative numbers and that's not going to be much fun. So let's go with n squared plus 2n minus 2303. Alrighty. We could have also done that when we rearranged it by moving all of these values this way. Either way, whichever makes most sense to you. Alright, we've got to factorize this again. So again, we know we're going to have n something times n something equaling nothing to do null factor. And again, I need to find out 2 factors of this that will make 2. So just like in the question above, I'm going to be looking for 2 numbers that are very close together. So there's probably a huge number of possible factors for 2303. So what I'm going to do is I'm going to square root 2,303 in my calculator, and that will give me the answer 48. Guess and check. I'm going to go one number higher and one number lower. So I'm going to say 49 and negative 47, because 49 minus 47 would make 2. Checking in my calculator again, 49 times 47. Yep, that does make 2,303. Fantastic. So they are great factors. So that means that to answer this one, n is 47 and 49, or n can also be minus 47 and minus 49. Question 5 wants me using the null factor method again, but I can't yet because null factor won't work unless our equation equals 0, and this equation does not equal 0, it equals 30. So we need to start rearranging. So let's take 30 from both sides. And my new equation will read 3x squared, it's supposed to be an x there, let's just tidy that up, 3x squared plus 15x minus 72 equals nothing. And now we can factorise it. It's going to be pretty tricky to factorise with that 3 sitting in front of that x squared, but I can see that 3 is a factor of all of those terms, so I can just take it outside. And now I can just ignore it, which is much better. So it'll just float along out the front of the fraction, sorry, the brackets there, without causing any problems. I need some factors of 24 that will make 5. Our pairs of factors of 24 will be 1 and 24, 2 and 12, 3 and 8. Those ones are looking good. I reckon I might try and make a 5 out of those. The next little thing that I'm noticing is this is a minus sign here. So that means that when I factorise this, the 3 just stays there, by the way, just ignore it. It'll be x times something, x. 8 minus 3 makes positive 5, so 8 minus 3 makes positive 5, so we factorise that. Nice and easy. That means that x will be minus 8, and it'll also be 3. And that little 3 out the front has no bearing on that, just ignore it. You just solve away like that, because it'll be 3 times nothing anyway once we make one of those factors nothing. Alright, let's do the next one. Bit more rearranging in this one here, because this one doesn't equal 0 either. Look, so first job, make it equal 0 for everything in this topic. So let's take 5x away from both sides, and the next line will now be x squared minus 7x plus 14 equals 2. Let's get rid of the 2, it's positive, so let's take 2 from both sides. I'll be left with x squared minus 7x plus 12 equals nothing. We're ready to factorise, so I know it's going to look like this. And I've just got to fill in the gaps. What are my factors of 12? So I'm looking at this 12 here now. They are 1 and 12, 2 and 6, 3 and 4. 3 and 4 look good for making 7. Let's see how we go. Next thing I'm noticing is this is a positive number. If that's positive, the symbols in both brackets will be the same. And because this one's negative, that means they'll both be negatives. Now I know that minus 3 minus 4 makes minus 7, so I'll fill those in, and we're factorised. So null factor, x will be 3, and it will also be 4. When we get to graphing, you'll see why x has got 2 values. But in a lot of these cases, x is going to have 2 answers when you do the null factor method. In question 6, we're going to solve using a different method. We're going to solve by completing the square. Sometimes the null factor method is not an option, and so we need to turn to the quadratic formula or completing the square, and this can also help with finding turning points later on. But let's have a look at how we do this. It's a bit of an unusual process, but I'm most interested in this part of the equation. So when I start to write this out, it's going to look like this. X, and then plus something, and I'm going to square the lot. And the thing that I'm going to put into this is I'm going to halve whatever this number is. So if this one's 10, this one's going to be 5. If it was a negative 10, it would become a negative 5, okay? So we're halving it. But then unusually, because that number was never really supposed to be there to begin with, what we do is we square the second number. So this 5, if we had expanded it, would have become 5 times 5. And in recognition of that, we're going to take it away because it shouldn't be there. Then we can't forget we had a little 3 up here in the equation, so we've got to add that back on. And this all equals nothing. Let's start collecting some like terms to clean it up. These need to stay as they are for the moment. And then I've got minus 25 plus 3 makes minus 22. One of the ways of solving these, and remember that we'll probably have 2 answers to this, is that I can sort of do it like the balance method, or it is the balance method really. I'll add 22 to both sides, and down here I'll end up with x plus 5 squared equals 22. Then what I'll do is I'll square root both sides so I can get rid of this squared, and x plus 5 will be the square root of 22. And remember, this could be positive or negative, okay? And then I'm going to take 5 from both sides. So that means that x will be minus 5 plus or minus the square root of 22. And as a final answer, we usually write, therefore, x is minus 5 plus the square root of 22, and it's also minus 5 minus the square root of 22. Strange looking answer, but that's what it is. If you can simplify the surd, you do, but often it ends up being left in surd form like that. All right, let's have a go at the second one, because it's a bit more unusual. So again, I'm interested in this part of the equation. So when I go to write this, it becomes x, and then half of minus 5 makes minus 5 on 2, literally half of minus 5 squared. Now, minus 5 times minus 5, and remember we have to square that. I'm going to do that over on the side over here. So if we've got minus 5 on 2 times minus 5 on 2, remember what this will turn out to be is 5 times 5 makes 25, 2 times 2 makes 4. So I've now got 25 quarters, okay? And so what I need to do is I need to take that away, because that should never have been there to begin with. So I'm going to take away 25 quarters, and I've still got that little minus 2, but that's going to be really, really hard to collect like terms. So what I'm going to do is I'm going to make an equivalent fraction. So 2 is really equivalent to 8 quarters. So I'm just going to change that to 8 quarters. And that way, these two are going to be easier to simplify. So in my next line, I've now got x minus 5 over 2 all squared, and then I've got minus 33 quarters equaling 0. And now I'm back to my balance method. Let's add 33 quarters to both sides. Now I'll have x minus 5 over 2 squared equals 33 quarters. I now like to get rid of this little squared here. So the opposite is to square root. I'll do that to both sides, and I'll end up with x minus 5 halves equaling the square root of 33 over 4. Remember, this can be positive or negative. And in the last step, I'm going to add 5 halves to both sides. So I'll have x equals 5 over 2 plus or minus. Now, the square root of 33 I can't do much with, so that's going to stay like that. But the square root of 4, because remember that applies to both of those values, is 2. So now everything's in halves and looks nice and neat. And just for the sake of convention, we usually write this out in one more step as, therefore, x is 5 halves plus root 33 halves, and it's also 5 halves minus root 33 halves. And that's the final answer.